Ground track is designed to continuously handle slowly changing levels of ground mineralization. Abrupt ground changes should be handled by re-ground balancing the ATX. In areas where the ground minerals shift enough to cause frequent re-ground balancing, then ground track should be used. When switched on, ground track provides slow, continuous tracking to ground mineralization. Be aware that even in its fast setting, the ATX ground track process is only designed to adjust to slowly shifting ground conditions. To change the ground track setting, press and release the Shift button to access secondary controls. Repeatedly press the ground track button to step through the 4 settings. Off is indicated by LED 1. Slow is indicated by LED 5. Medium by LED 9. And fast by LED 13. The green LED will blink during operation to indicate that the ground track feature is on. Be aware that ground track may reduce detection depth due to slowly tracking to a target, especially with repeated swings over the target. Therefore, ground track should only be used when changing ground mineralization requires frequent re-ground balancing. Press and release the Retune button to instantly reset the detector's audio and LED response back to 0. Use this function to quickly cancel out unwanted ambient signals, such as when the detector's audio and LED response has drifted to an elevated level. Accurate pinpointing of a target helps you to recover it quickly. To use the pinpoint function, place the search coil on or near the ground to the side of the target's suspected location. Press and hold the pinpoint button and wait for the single beep. Continue holding the pinpoint button and sweep the search coil over the target area while maintaining the same fixed height above the ground. Sweep the coil side to side and front to back in a crosshair pattern to locate the peak signal, as indicated by the strongest audio and maximum number of LEDs. The center of the target should be directly beneath the center of the search coil. To locate a target without the pinpoint button, sweep the coil side to side and front to back in a crosshair pattern over the target area while listening for the peak signal. In motion mode, it is important to keep the search coil in motion, wiggling back and forth to pinpoint the peak signal area. In non-motion mode, static pinpointing is possible without the use of the pinpoint button. Simply utilize the same front-to-back and side-to-side scans over the target area until your coil is over the peak signal, as indicated by the strongest audio and maximum number of LEDs. For best pinpointing results, maintain a constant coil height above the ground and ensure the detector is properly ground balanced. It is recommended to practice pinpointing in a test plot. The ATX's iron check feature can be used to audibly identify iron targets. Iron check only works with the Double D search coil and will not work with mono coils. If the iron check button is pressed while using a mono coil, a repeating dual tone warning alarm will indicate this to be an invalid action. To utilize iron check, move the search coil to the side of the target. Press and hold the iron check button and wait for the double beep. Then continue holding the iron check button while quickly scanning back and forth over the target with very flat, level swings. If desired, check the target again from different directions by rotating around 90 degrees. Maintain very flat, level swings over the target. Iron will produce a very low-tone growl or grunt sound that may or may not be flanked by normal tones. Non-ferrous and/or weak targets will produce normal tones, or may even be silent, but will not produce the iron tone grunt. Note that iron check is a conservative function by design. To help ensure the ATX does not misidentify a good target as iron, the iron tone, or grunt, will only activate on strong signals. Therefore, small iron targets or more deeply buried targets will not identify as iron. Steel bottle caps that are lying flat will typically not identify as iron. However, steel bottle caps that are on edge are more likely to identify as iron. Examples of iron targets that will produce the iron tone grunt are a 3-inch nail to a depth of about 5 inches, and a 3/4 inch boot nail to a depth of about 1 inch. In highly mineralized areas, iron check accuracy may be affected. Therefore, use flat, level swings to improve accuracy. All changes made to the ATX settings are saved when the unit is switched off. To return all settings back to factory values, press and hold the pinpoint button while switching the unit on. For best detection results, keep your search coil at a constant height and parallel to the ground at all times. Do not lift the coil at the end of your swings. Walk slowly as you scan your search coil in a straight line or slight arc from side to side at a speed of about 2 feet or 60 centimeters per second. Overlap each sweep by about half of the search coil's width to avoid missing any targets. In non-motion mode, a slower swing speed will further improve detection depth. The ATX is very sensitive, so be mindful that steel-toed boots or metal digging tools that come too close to the coil will be picked up. Be aware that the use of ground balance on any detector, whether PI or VLF, can reduce the maximum detection depth for some targets. Therefore, the ATX can be operated at its factory ground balance to obtain the greatest possible depth on most targets. This can result in increased ground response and instability, so the use of factory ground balance should only be done when your experience level and the environment provide acceptably stable operation. One of the two ways to obtain factory ground balance is to do a factory reset. The other method is to ground balance to air. To ground balance to the air, go through the normal ground balance steps, but do not pump the coil. Instead, hold the coil stationary about a foot above the ground and away from any metal. Remain in ground balance for about 4 seconds to allow the ATX to adjust. Repeat the ground balance to air process if needed. You should conduct bench tests with your ATX to become more familiar with its audio signals and operation in both motion and non-motion modes. It is best to test the ATX outdoors, away from sources of electrical interference, and several feet away from any large metallic object. To create the ideal bench test position, extend the ATX's lower stem and lay the search coil back on top of the stem. This allows you to keep one hand near the controls while still reaching the coil with your test targets. The ATX can be submerged in water to a maximum depth of 10 feet or 3 meters. Use of the detector below these depths can cause leaks and void the manufacturer's warranty. The ATX is shipped with land-use headphones that include a waterproof connector and cable. Do not, however, submerge the headset. Fully submersible headphones are available from Garrett as an optional accessory. For water hunting, closed coil covers can create excessive drag in the water. It is therefore recommended to hunt with either an open coil cover or with no coil cover attached to your search coil. After using the ATX in any body of water, it is very important to properly rinse the detector with fresh water before collapsing the stems. Salt water and even freshwater sediment deposits can inhibit the easy operation of the ATX nuts and stems. Detecting in salt water is more challenging than detecting in fresh water. To a metal detector, salt water has an electrical conductivity very similar to foil, fine gold, and other low conductors. Therefore, any technique used to eliminate saltwater response, such as ground balance or discrimination, will automatically reduce the detection depth of these low conductivity targets. This effect occurs for all detectors, whether VLF or PI. There are 3 methods to approach the saltwater environment with an ATX. The traditional method for using a pulse induction detector in saltwater is to increase discrimination or delay until the saltwater response is sufficiently eliminated. A setting of 3 to 7 on the ATX will usually eliminate the salt response. Ground balance is not required with this method. This method will maintain normal high and low tone responses, but will have the greatest amount of reduced detection for low conductivity items. Reduce the discrimination setting toward 0 when moving from wet sand to dry. The second method for saltwater use is to leave the ATX discrimination setting at minimum or one step up, and then ground balance to the saltwater to eliminate its response. Compared to the discrimination method, this ground balance method will provide better detection of low conductivity items, but be aware that all targets will now produce a low tone response. It is important to re-ground balance the ATX each time it moves to a new region of the beach, such as from wet sand to dry sand. The third option produces the greatest possible detection on low conductivity items, but comes with the penalty of having the most saltwater response. Return the ATX to its factory default ground balance by performing a factory reset or by ground balancing to the air. Set discrimination to minimum or one step up. This method should only be used if your experience level and the environment allow you to obtain acceptably stable operation. The Double D search coil can be used with this method to help cancel some of the saltwater response. For any of these methods, the following basic techniques will help to achieve the best performance for saltwater hunting. Swing the search coil flat and at a constant height. Do not bounce, tilt, or lift the coil at the end of swings. Hunt the 3 different regions of the beach, dry sand, wet sand, or submerged, one at a time rather than going back and forth between regions. This will allow the detector to be set optimally for each region. Swing the search coil parallel to the water's edge to minimize changes in moisture levels within a given swing. The detector may become less stable in shallow, breaking surf where the search coil is in and out of the salt water. In this area, the detector is encountering a constantly changing environment produced by the surf, making it more difficult for the detector to stabilize. Experiment with the saltwater methods that have been demonstrated to determine which you prefer, and if necessary, reduce sensitivity to obtain stable operation. Each ATX search coil is permanently attached to its telescoping stem assembly. To switch to another search coil, it is necessary to remove and install the entire assembly. First, fully collapse the stem and tighten the stem nuts. Remove the armrest by disengaging the armrest lock and sliding the armrest forward and off. It will be necessary to remove one battery cover to allow the cuff to fully slide forward. Disengage the stem rotation lock and, while continuing to hold the lock open, rotate the stem 180 degrees counterclockwise so that the coil is upside down. Partially slide the stem assembly out to access the coil connector. Slide the connector cover down the cable to expose the connector. Loosen and disconnect from the electronics housing by hand. Remove the search coil and stem assembly from the electronics housing. It is also possible to replace the ATX search coil without fully removing the armrest or one of the battery covers. Simply disengage the armrest lock and slide the armrest forward without removing it. Reinserting the connector and tightening the collar is done in a more restricted space, but this method does not require removing any parts. To install another search coil, collapse the telescopic stem completely and tighten the stem nuts. Then slide the stem partially into the electronics housing. Reattach the search coil connector by properly aligning the pins, fully inserting the connector, and tightening the collar by hand. Rotate the stem assembly to the 180-degree position, where the coil is upside down, and fully insert into the electronics housing. Disengage the stem rotation lock, rotate the stem 180 degrees, and release the spring-loaded rotation lock to automatically re-engage. The ATX uses 8 AA batteries. The detector is shipped with one set of alkaline batteries installed. The set of rechargeable batteries also included can be recharged from AC power or a 12-volt DC power source. The ATX accepts alkaline 1.5-volt rechargeable AA batteries or 1.5-volt lithium batteries. Do not use 3.7-volt lithium batteries as they can damage the detector. Both ATX battery packs should be replaced when the unit indicates low battery level. Average operation time with fresh alkaline batteries is 12 hours. Rechargeable battery time is 10 hours. The ATX battery compartments are located on both sides of the detector's armrest. Press in the battery cover, rotate a quarter turn counterclockwise, and then pull to remove. Tip the detector forward to allow battery pack to slide out. Reinstall the battery pack with the correct polarity, as indicated by the plus and minus markings on the side of the detector. Replace the battery cover and rotate a quarter turn clockwise to lock into place. Repeat this process for the batteries on the opposite side of the detector. If the ATX will be submerged, be sure to lubricate the O-rings on each battery cover with silicone grease. The ATX battery recharger accepts from 1 to 8 AA batteries at a time for charging. Use only nickel metal hydride type batteries on this charger. Do not attempt to recharge lithium, alkaline, or carbon batteries. 8 individual LEDs indicate the charging status for each battery. A steady red LED indicates rapid charging in progress. A steady green LED indicates the battery is fully charged. The soft carry case included with the ATX protects the detector during travel and when not in use. When properly arranged, it can hold the ATX, optional search coils, and accessories. To store the ATX with its standard double D coil attached, place the detector as shown. Secure the straps around the ATX's lower stem and housing. To store the ATX with its double D coil attached and the optional 20-inch deep seeker coil, insert the deep seeker coil into the flap as shown here, with the base of the big coil inserted into the pouch first. Use the Velcro strap to secure the deep seeker coil in the pouch. This same configuration should be used if storing the double D coil, the 20-inch deep seeker coil, and the 8-inch mono coil. The 8-inch mono coil can be snugged to the side of the detector and the ATX headphones. The ATX can also be stored in its soft carry case with the 20-inch deep seeker coil attached. Secure the detector with straps around the lower stem and the ATX housing. The standard double D coil should be inserted into the side pouch with its stem base facing out. To also add the 8-inch mono coil, angle the standard double D shaft as shown and place the 8-inch mono coil as shown. The ATX is a rugged detector designed for outdoor use in all environments. However, as with all electronic equipment, there are some simple ways to care for it in order to maintain its high performance. Avoid extreme temperatures as much as possible, such as storing the detector in an automobile trunk during the summer or outdoors in sub-freezing weather. Keep the detector clean, especially the touchpad and telescoping stem assembly. The ATX stems should never be collapsed and allowed to dry when the unit is muddy or sandy or after any underwater use. Salt water and even freshwater sediment can inhibit the easy operation of the stem and stem nuts. Rinse the unit under running fresh water to remove sand or sediment. Rotate the stem nuts back and forth and work the stems in and out while under the running water to help flush any grit from within the stem nuts. Flush any debris from the stem rotation lock as well. It is also important to clean out any sand or sediment where the stem inserts into the electronics housing. Follow the search coil removal procedure, but do not disconnect the search coil cable. Wipe down or rinse off the upper stem and the electronics housing, and wipe down the ATX with a clean cloth. If a fresh water source is unavailable after water hunting, rinse the unit in the body of water you have been hunting. Hold the ATX under the water surface while vigorously rotating the stem nuts back and forth and working the stems in and out to help free any trapped sediments. Leave the stem nuts in a loose, untightened midpoint position for storage to prevent any remaining deposits from seizing up the stem nuts. When storing for longer than 1 month, remove the detector's batteries. Install the protective cover on the connector when not using headphones. An advanced cleaning process is possible if the ATX stems become difficult to extend and collapse over time. Garrett offers this optional spanner wrench to remove and clean the interior stem nuts. Use the spanner wrench to loosen the lower nut retainer by turning counterclockwise. Slide the retainer back. Remove the black plastic puck. Pull out the lower stem assembly and this plastic shim. Simply wipe or rinse these parts and stem threads, or clean them with soap and water. Do not use any solvents or lubricants. Snap the plastic shim back into the shaft openings. Insert the stem until the edge of the black shim lines up with the stem opening. Place the black puck into the opening as shown and slide the collar over the puck. Thread the nut retainer into the collar and tighten with the spanner wrench. Do not over-tighten. Repeat this process as necessary on the other 2 stem nuts. To clean the upper stem nut, it will be necessary to loosen this case ring and slide it back. After cleaning is complete, slide the case ring back into position as shown, making sure it snaps properly into the 3 stem openings. This is again an advanced cleaning process that will not be necessary for most users. Those who use the ATX for extensive water hunting may find this to be a helpful maintenance program to use periodically during their hunting season.